Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 3418, maximum amount of money robot can earn. So this is Funda, and please subscribe this channel to understand the problem in detail. So this problem is very fantastic about the robot, how the robot moves in the grid. So yesterday we have already seen the robot collision, right? Problem number 2751. This is the another problem where the robot earn money and some important concept we have. So let's try to understand in detail. So let's suppose that the question says that we have given, right, m cross n grid where we have to find that maximum amount a robot can earn. Okay, so how the robot can earn? Basically, the problem says that a robot will start moving from grid cell 00, the origin cell, right, the very first cell, and it will reach to the last grid m minus 1, n minus 1, where m is a row and is a column. Okay, so this grid is given, right, that is called coin grid, and this grid name is coins grid. Okay, and we have given the robot can move from each cell, right, either wherever he has, right, any of this cell I'm talking about. So he can move either a right direction or the left or the down direction. Means let's suppose if he is at 00, so he can either go to the right or he can go down. Okay, he cannot cross the corner one. Okay, or ups and this side. Okay, left side only he can move two direction, right and down. So this is the thing we have given. Now what does it saying? That let's try to understand. Okay, the question saying that the grid contains value coins at I. Coins at I means some value we have on this grid, right? If some amount should be there on each grid value. So it is saying that the grid contains value, and this value is called coins at ij, right, in each cell. So if the coins at ij is greater than uh, 0, right, it means robot gains that many coins, right? Whatever the coins value will be there, because its value is greater than 0. If greater than 0, it means he can uh, get some coins, right? Some many coins he can earn. But if coins is less than 0, it means it robot encounters a robbery. Means some value was there, let's suppose, or it less than 0 is there, right? So robot encounters a robbery. Okay, and robot, so the robot encounters a robber, means he got a robber, but this robber steals the absolute coins value here. Means whatever the value we have here at these coins, this robber steals that value. Okay, now what happens? It happens that the robot's ability to neutralize the robot, so admits two cells on its path. What is the robot ability? Robot ability that if the he found the robots, right, so at most 2 point what he can do, means at two cells, if he find the robber, right, he can neutralize him. Okay, and so the robber will prevent from the stealing the coins from those cells, right? In the entire grid we am talking about, there is two cells only, at most two cells are there, where this robber these robbers will be neutralized, means whatever he has earned, this robot will make it 0, right? And he prevents actually from the stealing. Okay, means at that, let's suppose some cell is there, let's suppose some cell is there, right, and he's the robot is moving ahead. He found that there is a robber, So whatever the amount he had, he made 0 at that cell. Okay, so that robbery will not happen. Now the robot total coins can be negative. Okay, the robot's total coins can be negative, and so the maximum profit of the robot can, we have to with the gain of the route, means how the robot start from the 0 0, right? And it goes to either left, either it goes to the right or going to down. So if he is moving from 0 0 to the last cell, m minus n, m minus 1 and n minus 1, right? It means he is earning some value. So whatever the gain we have, so we have to maximize that profit and we have to return. This is our goal we have. Okay, so let's think that we have this example, right? So example we took like this, right? We have 0 1 minus 1 1 minus 2 3 2 minus 3 4, and these are the its cell grid position. Okay, the very first is 0 0 0 1 0 2, and similarly 1 0 1 1 1 2 2 0 2 1 2 2. I have written so that you can understand how the grid works and how the grid is there. Any issue is there, please let me know in the comment section so you can understand. So let's suppose this grid and the maximum value is, we maximum coins we are getting is, the robot getting is 8. Okay, so how we will solve this problem? This is what the question saying, that we have understand till now, right? What are the things we have here? So the question says that we have to find the maximum amount of the money the robot can earn. This is the grid we have. Robot can move either right and down. Then if the cell is greater than 0, what will happen? Cell is less than 0, what will happen? What is the robot ability and what we have to do? After that we have given this example. Okay, and answer is 8. Let's try to understand further. Now the question is, what is the optimal path for maximum coin? So the optimal path for the maximum coin is, let's suppose that we will start from 0 0. It means we will start from this position, right? So what is the value we have here is 0. So the total coins value is 0. Now it will move to either right or down. Okay, so both value is 1 1 only. Okay, so what we will do, we'll say move right at this position 0 0, and you will move to the position 0 0. So you will get some gain. What is the gain is here? 1. It is greater than 0, so you will get the gain. And so the previous was 0, means here it was 0, this is 1. So 0 plus 1 you will get is 1. After this position, where it will go, either this position it will go or this position it will go, right? So we'll say okay, move down. As you can see, it is saying move down. So what will happen? We'll reach to the 1 1. At 1 1, what we have value is minus 2 we have, let's suppose. So we'll say the robot, where there is a robbery still, right? So robbery still is happening because value is less than the value, right? So we'll say how many coins are there? 2 coins are there. The robot uses a neutralize point here, neutralization he will do, and he will avoiding the robbery. So what will happen? These coins will be not steal by the robber, so robbery will not happen, and so it will marked as a 0 because it has been neutralized. So once it neutralized, the value becomes 0. So still the total coins value earning is the previous one only, so it will remain same, no addition, no gains will be there. Next we will move to the 1 2. So we are at 1 1, so we will move either this position or this position, right? So we'll move to this position where we'll get 3. So it is saying that step 4 we'll move to 1 2, right? So the gain is what we are getting 3 here, so we'll add 1 plus 3, we'll get the 4. After reaching to this position, we have to move either right or left. So right, the boundaries condition is completed. It means you will go only down. So you will reach to the last position, that is 2 2, and you will get the coin is 4. So previous was 4, the new one is 4, 4 4 is 8, and you got the output of this example. Okay, I hope you understand how to start, right? Means how the robot will start moving, right? And how will reach that position. Once you will reach the position, he can keep going ahead and he can reach the position. And what he in middle of the robbery, if he found the value, right, he can do the neutralization also. Okay. So this is what we have to do. Now the thing is how we'll solve this problem, right? So let's suppose that very first approach is memorization, right? Memorization we do. So with the help of memorization approach, we can solve this problem. But before going in the deep, I'll suggest keep watching here the concept how this problem works. So it's a similar kind of a problem, guys. That is why I have written this. It's a similar kind of problem. If you have gone through the lead code problem number 64, right? This is another problem. This is completely different than the current one that we are discussing. So the current one we are discussing is 3468 maximum amount of money the robot can earn. So this problem is similar to the problem number lead code 64, as you can see here. Minimum path sum problem. The lead code problem number 64. What does it happens? It is saying that you have given grid where each cell has a number. Some value will be there. As you can see in this example, we'll discuss more. Okay. So let's suppose you have given this problem, means the problem is given and problem said that you have given grid. Each cell has some number like this. So you will start at the top left corner, that is 0 0, and you have to reach to the last position bottom right, that is m-1 and -1 coordinates. So it is saying that it start from the 0 0 and goes to m minus n minus 1. So these coordinates are the uh, starting point and the reaching point, last point or target point. And then it is saying that how we'll move. So move either right or down. So either you will move this direction or this direction as we have given in our problem, right? So the lead code problem number 64 says this is we have given. Now what you need to do, you have to find the minimum sum path problem. Okay. So how will you find the this path problem? So you have to find the minimum path sum and you have to return the output for this example, this problem. So let's suppose this is the example we have given. So let's suppose how will I iterate over this. Let's suppose we start from here. So we'll go either down or this side, right? Like that we will find. So I'll suggest, I'm not suggesting, let's suppose you will start from 1, you will go to 3, then this one, then this one, then this one. So all you are getting is you are adding the value, right? You are getting 7. Other than this, if you'll take any other path, you will get more value here. So you will not return the minimum, you will return more than 7. That is why this is the possible path, right, where you will return the minimum value. Now how we are going to solve this type of problem where we have to return the minimum path sum. So in that problem, this is the intuition of this problem number lead code 64. Okay, 64 problem, lead code problem number 64. So at any cell, let's suppose called ij, we can only move, right? Let's suppose the grid we have here is, okay, let's suppose this is our grid ij. So we can only come from the top or the right? So the top is this one I minus 1j, right? And this left one is nothing but I and j minus 1 for this cell. So if we are at this cell, only two path we have from where we can come to ij. Top I minus 1 and left I j minus 1, right? Now Now think that we have to find the minimum path to reach the ij. Okay, means how we'll find the minimum path. So minimum path is, if we want to find the this path, some value will be at this grid, right? Means let's suppose some value is there. 8 we have, 1 we have, 2, some value will be there, right? So that value plus minimum between these two. So we will take the minimum and we will take the path from the top, which is coming from this path and which is coming from this path. So these two paths you will add. Path from top, path from left. Now we have is DP formula. So how will we apply this DP formula? So as you can see that we have grid and we have to find the minimum path between the top left path and top or left path, है ना? So how we'll find this problem? So we have the DP, right? So let's suppose we'll create a DP and we'll store this path will store, because there will be many paths, right? As we have one path for left top and one path for the right. So for this is for only one cell we are talking about, I say. So there can be many cells, right? As you know that this is a grid, right? So for each cell there is one path coming from here or one path coming from here. So we have to store what is the path that we took here, minimum. What is the path we have to for the minimum? So we have to take each path the minimum and we have to store somewhere. So we'll take the dpij and at each coordinate means ij will store the minimum path, that is called grid ij plus minimum between I minus 1 j, which is top, and I j minus 1, which is from the left coordinate. Means we are talking about these two coordinates, which is coming from here and here, right? So we'll store like this. I hope till now there is no issue is having, right, in understanding the problem, right? So let's suppose that what we need to do further. Further we need to do is stepwise DP building. How we are building, how we will build the DP array and will solve this type of problem. So let's suppose that we will start filling the grid itself, means in place we have to fill, so that we will not create a new DP array. So what we need to do, will let's suppose this is what we have to do. So very first that we will fill the first row. So we'll check that, let's suppose we'll develop the very first row, that is the very first row we have is 1. So we'll take 1. Then if we are coming to the next cell, so next cell only we can come from here because there is no top, right? If no top is there, it means this one and this current value will store. 1 plus 3 is 4. Then we'll reach to this one. Similarly, we have currently 4. So when we reach here, so what is the value which is coming from here to here? We'll say, okay, from here to here, we already has calculated here. So this is our 4 now. So 4 plus 1 is 5. So we'll store 5 here. Means we have to calculate the very first row. Similarly, we have to calculate for the this row. How we are storing? The very first row is 1. And if you are coming to this cell, you can come only by this way, not this way, because top we have existing for these two cells, right? But left is not there, right? So very first is 1. So we'll store 1 here and we'll say, okay, when we come to this position, what will happen? 1 plus 1 is 2. So we'll store 2 here. So till there, we have come from here to here. Now it is 2. This 2 and this 4 become 6. So we'll say, okay, this becomes 6, as you can see here. Understand? Now what about these cells, right? These cells we can calculate. Either we can come here, from here or here. So each cell other than the first row and first column, column and first row, these cells have a path which can come from the top and the left too. He can come from the top and the left, can from top and left, top and left, like this. These are the cells which can come from the top and left. So for that we have to fill the rest. How will fill the rest? We already know that this is filled, this is filled. So let's suppose I want to calculate this one. So we already know that this is 1, this is 4, right? So this value is what? So if this is 3, so we'll choose between 2 and 4, right? So I'll say, okay, what should be the value here? So let's see. The very first thing that we already seen that this is 5, right? And we have already calculated what? We have calculated 1, 4 and 5. So between 4 and 2, which one is small? The 2 is small, right? So what will I do? I will add into 5. The 5 plus 2 is 7. So this value will become 7. Similarly, we'll check this how this 6 happens. So this previously it was 1. So we'll take from the top, right? Because this is 7 and this is 5. Which one is small? This 5 is small. And this is 1, right? So we'll say 5 plus 1 is 6. Like that, we'll take these two value also, right? It is 7, so we'll take 1, 7, 1, 8, and this is 1, so we'll take this 6, not this 8. This becomes same. Like this, if you see here, you see that this is 1, 1, and this is 2. So this is 7, and this is 4. This is 7, and what is this value? 6. 6. So we'll take 6, and 2 is 8. And for this position, we'll take from here or here, that we have to choose. So like that, we will fill all this value and you will have the final array, right? That this is called DP array. Okay. And you will find the what we have. We have to return the m minus 1 and n minus 1 coordinates value, means DP at n minus 1, n minus 1. And this is the value we have is 7. So we will return this 7. Now the point is how we'll solve this type of problem. The very first thing is we have the grid we have given. So if grid we have given, means we have given m we have given and n we have given, correct? So we have to calculate like this, so that we will think that this we have given m and n. Now we'll complete the first grid, first row we can say. We know how to how to add. We know that it will only come from the left. So we'll just say at each cells we will add grid at 0 and j, right? Means we are talking about only j, the row I is here 0, but j is changing, right? So what we'll do, 0 j means the very first row we are talking about, it become this value, means we are talking about the step 1. We are building this as step 1, means what is the row here? Row is 0 for all these cells. All these cells row is 0, right? And j is 0, 1, 2. It is increasing. Similarly for this case, right? Here what happens? Row is changing, but column is same. So these two conditions we have to use. The very first condition is this, right? For the first row and for the first column, right? I0, it will start from I minus 1, 0, means top to down it will keep going, right? What is on the top? Take that from the top and add into the here, right? Like that we will do at this position. So this is easy. So we have calculated how the first row and first column. Now we talk about the remaining cells. How will it solve? So we know that we need I1, J1, and we'll go to till the M and N, right? The row and column. If we want to find the what we have, what should be at the grid I and J, right? Because we are using the in place, right? It means we'll use the same grid, right? We are using the same grid. So math dot, this is we can treat like DP as a DP. Okay. So math, we'll take the math dot mean and I minus 1 j, and means we will talk the row which is coming from the top and which is coming from the left. Which one is a small one? That will keep adding on the current cell, right? Like that we will do the in place of all the value. First we have done all the row, all the column, and the remaining cells we have also done till now. Finally, dp m minus 1 n minus 1 means we are treating this grid because we are doing the in place. So we'll return the grid m minus 1 n minus 1. So this will work like as a dp or memoization, we can also say that. Okay. So in this case, we'll take O of m cross n and O of 1, because O of 1 will take because we are using the same grid, right? And that is called in place. So this question is very important, guys. That is why I have talked about, so you will understand how the question works, how the grid works in the case of if the robot moves from any cells. So why the grid fails? Because grid fails because if you'll take the mean local mean value, right, and if you think that we'll return that value, which will be, we will track the minimum, right? It means it will not be equal to the global mean. So in that case, the greedy will fails. Okay. So what are the possible variation that can be asked in the interview based on this question, right? So first we have seen that we have to find the minimum path sum, right? And then we have is minimum path with the obstacle, which Microsoft asks. We can talk about this video in future. I can ping me, I can put in the link also. Then we have the minimum path with the diagonal moves. Then we have maximum path sum, and then we have a return actual path, not the sum. Right? I mean, this is the same problem, but we have to return the actual path, not to the sum we will return. So these are the existing problem we had, means the possible variations of this problem when we return the minimum path sum. So these are the other problem that can be that used to ask in this in the interview. This is the new variation that I have observed and I have seen, that is called the Leetcode problem number 3418 that we have started talking. The maximum amount of money the robot can earn. So let's continue the intuition about this problem. So we have understood how to solve this type of problem, right? The problem says that a robot can neutralize the robot here. This is the single thing we have in this new variation, that the robot can neutralize the robot in at most two cells. It means what is allowed? Allowed is two modifications, means robot is allowed to two modification he can do on along the path, right? Then we have, if we compare the Leetcode problem number 64 with this problem, right? The minimum path sum problem that we have already talked, then you will see that it introduces an additional constant on the number of allowed modifications along with the path, right? So we will use dp again and we can solve this problem. Or memorization you can also use. Since the robot can only move right or down, we have seen the number of allowed modification is at most 2 only. It means we have to define I, j and this k, because this is the new state we have, is number of allowed modification. So we'll treat this k as a number of allowed modification. Other than that, we will use ij. So this will give you the maximum number of coins that can be allowed when moving from ij to m minus 1 n minus 1 with k remaining modifications and utilizations, we can say that. And we know what we have given. So at each position, what will happen? We will consider two cases. The case 1, don't neutralize, and case 2, neutralize. Neutralize means whenever he will see the rover, he will neutralize that value. So if we will not neutralize, what will happen? Means we will collect the value at these coins and will continue moving right or down. It means DFS will do IJK and we'll check the maximum value, right? Maximum, it means DFS IJK. So I will go to I plus K J and another will go for I J plus 1. Means either you will go the right direction or the left direction, either down direction, right? And what is the maximum it is coming, because we have to return the maximum value, right? And the current count of current value of the coins, right? In this case, you will keep finding the maximum. Case 2, when we'll see that if k is greater than 0, it means coins at ij is negative. Okay. If k is greater than 0 means still we have one modification allowed, right, at least, or some modification is allowed, but the value at coins is coming is a negative because we don't want the negative value, right? If we'll add the negative value, obviously this value will become negative or minus, right? So we want to not take that value. So whenever we'll find that coins at this value is negative, we'll neutralize this cell. That is called case 2. Because if we'll not do that, right, it will reduce our max value. Okay, so what we'll do, the resulting in 0 coins and will continue means that current cell is a negative value, so we'll mark it as a 0 coins and we'll add. So what will happen, so this formula will get changed, so we will using the maximum between these two, right? So this value become 0. So once this becomes 0, it means we don't need to add here. So how will move, so we know that, okay, in this case I plus 1, but I plus 1 j here will become k minus 1, k minus 1. So one modification, because we are doing the neutralization, means at least one k minus 1 will happen in both cases only, but the remaining thing will be the same here. Only what will happen, will reduce this as a 0 and we are reducing one uh, modification or neutralization. So we take the maximum of these two, right? So we know that we have only these two cases, these cases and these cases, right? So we have to take the max between these two cases and now consider the base cases. So what is the base cases? Base case is if I is greater than or equal to m or j is greater than or equal to n. It means this is invalid state, means in this case you return minus infinity. Then we have is if I and j is the destination, right, means we are already at the last cell, destination cell. It means if k is greater than 0, we may neutralize that cells. Okay, because we are left with what, we are left with some modification or neutralization we can say. So we have to neutralize the cell. It means we'll return the 0 and the coins at that last position what we have. Okay guys, so we have to return otherwise what will happen, we will return the coins at this position. So we will return these coins, right? Okay, so what will happen, this is the base cases that we have talked about, right? Otherwise we'll return the coins. If it is not at the destination, he will return these coins. And then we'll start from, and then we'll start from, because we are starting from 002, this is the two modifications required. So we'll say dfs 002 and this gives you the final answer. Let's talk about the notes. Notes is coins at ij can be negative and it results in the negative value. If it is the negative value, obviously it will also result in the negative value. So will therefore the memoization array should not be initialized with -1. It should initialize with, better to use instead of that some smallest value. Okay, so let's think how we'll initialize this value. So we know that we have to find these two things. We'll take a memo value I, j and k. So k will be maximum 2 modification required, so we'll take 3. Then we'll start from I and j and we'll fill with the smallest value. I will not take a negative value. Then we'll do the dfs, right? Dfs is what, we know that coins we have and memo we already filled. Then I, j and k will pass. So this is the function we have to create. So this function will get called to here, where we have these coins, grid we have, then memo we have given, and I, j and k we have given here, right? So once you will check that condition, right, means if the very first base case we are talking about, right? If the base condition is failing, you will return the minus infinity or the negative value or return x. Okay, so how will return the value? So very first, the current cell is called the cell value x. So we'll check that if we reach the another base case condition, will check if we reach at the last position, that destination position, then and we still left with the k is greater than 0, means some modification left, right? If it is true, so we'll check the maximum between 0 and x, what is the maximum. Otherwise, if it is not greater than 0, we'll say that return x, what is the current position we have at this destination, that value will return. Okay, now what you need to do is you will check the memo. If it is not equal to this value, means we have some value already calculated, so we will return that value. Otherwise, when you will not neutralize, that thing you will do means you have to take the max value, and you know that I plus 1 j, I j plus 1, and what is the x we have. So we'll take the maximum between these two and the current value, and we'll update this as a result. Similarly, for when we neutralize this k should be greater than 0 and the x value should be less than 0. In that case, we will do the neutralization. So very first, we'll check that what is the maximum. So the current maximum which is coming, that one, and another the max between these two coins will check, right? Means I plus 1, j plus 1, and there will be k minus 1, k minus 1. We will not do plus x because x is already minus, so we will not add. And we will keep iterating over the value, right? And we'll utilize all those modifications because we are doing k minus 1, k minus 1. So each time, each iteration will reduce 1 k minus 1. Okay. And once we will come the k equal to 0, in this loop we will not go. And like that, once these two neutralization cases done, you will update our res and you will return this res. So this is the approach, guys, we are doing for the memoization. You can also do better, right? So in this case, time complexity will look like this. So you can also use the dp approach. You can convert this approach into, you can convert this memoization approach into the dp bottom up. What you need to do is you will take the dp at ijk number of maximum number of modification when it is collected, when we're moving from 0 to the ij using at most k neutralization, right? So sorry guys. So at each cell, what will happen? We do not neutralize, we add the coins. If we neutralize this, we gain 0 from that cells. So now we'll consider the transition, that the base condition, what will happen. So if k is greater than k is equal to 0, this is the value we will store directly. If k is greater than 0, means we have to find the maximum, right? And we'll store. So very first row, you know that we have to add the first row, right? So how will find the first row? You will take the maximum, right? The current value with the coins, and I and the this value, right? Then first column, similarly we'll use these two and this value what is coming. And in other cases, we'll take I greater than 0, j greater than 0, means we have to take these values, right? So what will come is that will become our maximum. And finally answer will become is dp m minus 1, m minus 1, and 2. Let's see the code. So very first, what you need to do, you will define the dp grid, and you will fill with this value. Once you will fill this value, you need to do for the first row, right? You will check k is equal to 1, k is less than, sorry, this is we do for the modifications. So we'll find the modification, number of modification, I will check it, and we'll update our dp 0 and k, right? Similarly, we'll go for other nodes when I is equal to 1 and j and k is equal to 1. So we already know that this is for the 0j and 0. So we'll take that what is the value we have, so we'll store directly here. Then we need to find all the k, right? K from 1 and k equal to 2, because 0 we already done. So we'll update our 0j and k, and we'll take the maximum between these things, and we'll update our k. Here we'll use 0, j minus 1, k, and the current cell value j, this will become 0, j minus 1, k minus 1, and the maximum between what we have is here, right? Similarly for other cell we'll do, right? I to m means the column one, and we'll do the modification in the uh, similar way we'll do for the we have done for the other part for the k, means row and column we are talking about. When I and j both are coming in this time, so we'll find the dpij 0. When modification with the k is coming, right? So k is 1 to 2 will go, and we'll find ijk for all other cells. So we'll take the maximum between, so you have to take the first the max I minus 1 j k, I j minus 1 k, and the all other value. So this is your current value, current cells, and the max between these two value, I minus 1 j, I minus 1 j, but both time k minus 1 will happen, right? Like that we will update our dp, and will return m minus 1, n minus 1, and 2. So this is little complicated, right? But this approach is very good, because we are updating, we have converted into a uh, memorization. Okay guys, so I'll put the code in the comment box, you can go from there. We can further optimize this space, since it depends on only on the previous row. So we can use the rolling array, and we'll reduce the complexity to the O of n. For the correctness, so we iterate k in descending order when updating the states. So in this approach, what we will do, we'll do the same thing till now here, but we'll use the dp 2d grid, and we'll utilize this one. So very first you will initialize 0 to n, and then for all the points, right, you will go for the j. So at each j, right, you will get some value, and you will treat this, you have to find the maximum. So j and 2 will find, then dpj1 will find, and dpj0 will find. All these cases fine. So your dpij is ready, and you just need to do what is the dp at n and j, you will return the answer. So this is for the optimization of the space optimization, right? I know I was little bit fast in these two approaches, but I know that you will understand. In case you are not understanding, I can create another part of this video, and we can discuss more about the dp approaches, right? But I'll suggest that if it is okay with the memoization, try to do by yourself this dp approach. Otherwise I'll create another video where I can explain in detail. I was trying to complete this video in very short term, but there is a good thing that we can do a lot of things with this problem. This problem is very important, so I thought to give you complete idea. But still, if you are struggling with the dp approach, let me know in the comment section. I can create another video for you, and we can discuss in detail. Thank you so much. Give a like, subscribe this channel, and you can join my online classes where we can understand. You can join our both classes. Okay, so that's all I have in this video guys. Thank you so much. Let's continue.